Hi guys, my name's Tom. I'm an engineering geologist for Wessex Water, and I'm also an ex-student of Ian's who taught me A-level geology at Worthing College about 6 or 7 years ago. Since then, I've studied geology at Plymouth University, and since graduating, have worked as an engineering geologist for just over 2 years. This presentation is something that I originally produced to show the rest of my team, which includes several civil engineers and structural engineers. Um, as a sort of introduction to the geology of the region that Wessex Water supplies, um, really just to help them understand the variety of ground conditions that are encountered in the area and the effects it can have on structures and pipelines and the challenges involved with installing them. Um, However, when Ian asked if there was something I'd like to contribute to this great Facebook group, I thought that maybe it would be of interest to other people as well, especially as the Wessex region houses some of the most interesting and famous geological sites in the UK.
So this presentation is broken down into 5 different sections. The first section is a brief introduction to geological time, just to put things in context. The BGS separates the UK into different geological areas, and the Wessex region covers 3 of these different areas. So the first one I'll talk about is the Hampshire Basin and the surrounding area. The second one I'll talk about is the southwest of England. And the third one I'll talk about is the Bristol and Gloucester region. I'll also be talking about the Mercia Mudstone Group, which is found across most of the Wessex water servicing area. So here we have the older half of the geological timeline. And it's important to note that the date here is in millions of years. So for instance, at the bottom of the Hadean is 4,560 million years ago. So the geological timeline is split into the Precambrian and Phanerozoic, and the Precambrian is further divided into the Hadean, the Archean, and the Proterozoic. This part of the geological timeline accounts for 88% of the Earth's geologic time. So it starts when the Earth was created approximately 4.5 billion years ago. The first life on Earth appeared approximately 4,000 million years ago, and these were single-celled organisms. The photo here shows stromatolites off the coast of Australia, which have been found in the fossil record as some of the earliest life forms on Earth. And oxygen first started accumulating in the atmosphere approximately between 2,300 and 2,500 million years ago. Before this, oxygen was previously being used up by unoxidized sulfur and iron, but eventually these ran out. So then after this, oxygen could then be released into the atmosphere, which led to life forming. So this is the Phanerozoic, which represents the more recent and younger half of the geological timescale. While the Precambrian ranges from the formation of the Earth through to the beginnings of extensive life on Earth, the Phanerozoic covers all of the time period for which life has existed. So in the Cambrian, which is the first period of the Phanerozoic, animals first developed hard shells and become preserved in the fossil record. For instance, this trilobite here. Another key event is the Ordovician-Silurian mass extinction event, which resulted in approximately 60% of invertebrates on Earth going extinct. Another key event is the first terrestrial plants developing in the Silurian. This is an artist's impression of what they may have looked like based on fossils found. The Pangaea supercontinent forms in the Permian, which was when all of the continents on Earth were joined together in one supercontinent. Another mass extinction event is the Permian Triassic mass extinction, which resulted in 96% of all marine species and 70% of terrestrial vertebrate species becoming extinct as a result of a few different factors which are still debated today, but includes the Siberian traps, the large volcanic eruptions in Siberia, possible meteors, and climate change from methane released during this time. And possibly the most famous mass extinction event is the KT mass extinction, where approximately 75% of all species went extinct, including the dinosaurs. So this is thought to be from a combination of meteorite strike, which the crater of which has been found in Mexico, and also the Deccan traps in India, which was another large-scale volcanic event which released a lot of toxic gases into the atmosphere. And one of the more recent key events in the Phanerozoic is the descendants of humans beginning to evolve in the Neogene from approximately 23 million years ago. Okay, so now we come to delving into the geology of the Wessex area. So this is a map showing the region with which Wessex water covers. It's split into areas where we supply water and sewerage services. Some areas in yellow where we just supply sewerage services, and a few smaller areas in light blue where it's just water that we supply. So this is split into the Hampshire Basin and surrounding area, which covers this area on the map. The Bristol and Gloucestershire area of the Wessex, which you can see in light green here. And the area of Wessex, which is classed as southwest England geologically, covers this smaller area. So the first area I'm going to talk about is the Hampshire Basin and surrounding area, which, as I mentioned earlier, the British Geological Society splits the country up into sections geologically. This map shows the extent of that region, and only some of this is within the Wessex area. But this map shows you the extent of the geology, with young rocks along the south coast, with chalk dominating the bedrock a bit further north, for instance under Salisbury Plain and the Dorset Downs. And you also have Jurassic rocks formed from comprising Kimmeridge clay and the oolite groups of Portland. So this region forms the western part of a deep basin filled with sediments, which were laid down in ancient seas, and it is well known geologically due to the existence of quarries, many shallow boreholes, and there is a good extent of coastal cliffs. For instance, here's a photo of West Bay on the Dorset coast. And the chalk is also relatively well known due to deep groundwater boreholes that have been drilled into it, as the chalk is a great aquifer for groundwater. The Hampshire Basin and the surrounding area contain superficial deposits, which are widespread in the area but are a bit patchy and primarily comprise alluvium, river terrace deposits, and tidal flat deposits, and are generally associated with major river valleys in the area and the coast along the Solent. Here is a screenshot of the geological map produced for the area by the BGS, showing the extent of some of these superficial deposits here, where the area circled is a sewage treatment works we have, and it's just north of Bournemouth Airport here, and the whole area is underlain by river terrace deposits and alluvium, which covers quite a wide area here. So mainly comprises clays, silts, peats, sands, and gravels, and generally they're between 5 to 10 meters thick. These superficial deposits are very recent in terms of geological time, mainly forming in the last 2 to 3 million years. spanning ice ages and the interglacial periods. The river terrace deposits here form as rivers move and then deposit the material, whereas the alluvium is more recent, associated with current rivers. The structure of the region geologically is that of a large syncline fold, so meaning that the younger rocks are exposed in the center of the fold and the rocks increase in age outwards towards the outer limbs. And this fold is roughly east-west trending in the region, and the whole structure forms the Hampshire Basin. So to the north of the syncline, the dip of the limbs is relatively shallow, but as you reach the southern edge, there are steeply inclined rocks, which can be seen very clearly on the Isle of Wight, and also along the coast at Durdle Door and Lulworth Cove. So on this cross-section here, you can see towards the Isle of Wight, the angle of the beds increases very sharply. In this photo here, you can see what I was just mentioning about the angle of the beds here, almost vertical. And this is adjacent to Durdle Door, and I believe it's in Man of War Bay, which is just located to the east of Durdle Door. So the next oldest rocks in the Hampshire Basin are formed from sedimentary bedrocks, comprised of soft alternating layers of clay, silt and sand. Here on the map you can see them represented in the orange. So they were deposited between 60 to 35 million years ago in shallow sea environments, and they can be found in the Wessex part of this map between Dorchester through to Ringwood and then up towards Salisbury. So you can see mainly along the south coast here and heading a bit more inland north of the New Forest. And these deposits rest on top of the chalk. The chalk is the next oldest lithology in the region, and it is a very fine-grained limestone that's more frequently white, but also pale grey in colour. And the chalk is formed from billions and billions of microscopic coccoliths, which are the calcium carbonate plates that form from microscopic animals called coccolithophores. Here's a photo of a trial pit I took up on the Dorset Downs. You can see how close the chalk is to the surface here. It forms the most important aquifer in southern England as the water flows through the abundant cracks and fractures within the unit. This can also result in voids within the chalk. As the water flows through it, it can erode the chalk, and you can end up with large voids within the rock, which can be a problem for building structures on it. The chalk deposits form the Dorset Downs and Salisbury Plain, so they form some of the bigger hills in the southern part of England. And the chalk can be up to 400 metres thick at the centre of the Hampshire Basin syncline fold. So underlying the chalk in the region are rocks from the early Cretaceous. These are deposited between 145 and 100 million years ago in shallow sea and lagoon environments. And this includes the Upper Greensand Formation, the Gault Formation, the Lower Greensand Group, and the Wealden Group, which are all quite widespread groups throughout the south of England. And this photo shows some of the outcrops you can see on the southern coast of the Isle of Wight, and you can see they're quite thick here. So the next oldest rocks in the region are of the Jurassic Age. So these were deposited between 205 and 145 million years ago, and they comprise thick mudstones which contain thin limestones and sandstones, which are overlain by shelly and sandy limestones. And the mudstones were deposited in deep sea environments, whilst the limestones were deposited in sort of shallow tropical reef environments, which reflects the changes in sea level which were happening at the time. Here's a photo of some of the rocks exposed along the Jurassic coast. So they are exposed along the extent between Portland and Lyme Regis, and also inland as well, from sort of west of Yeovil through to Wincanton, Frome and Trowbridge up towards Chippenham. But obviously they're more famous along the Jurassic coast where they are exposed very well. This is a photo on Portland Bill where the sort of Jurassic Oolitic limestones are displayed very well. This includes the Lias, Oxford and Kimmeridge clays, as well as the Oolite, Corallian and Portland groups, which you can see in the photo here. And Portland stone, which is mined at Portland, is a world-renowned building material, with famous buildings such as St Paul's Cathedral being constructed from it. And this Jurassic sequence can be up to approximately 1.4 kilometers thick beneath South Dorset, so it's a very thick succession. The next geological region, which I'm going to talk about, which is within the Wessex Water region, is the southwest of England. So here is a map, a geological map of the region, and only the eastern section of this is included within the Wessex Water region. So approximately east of Lyme Regis up through northwest towards Minehead is within the Wessex region. Obviously, most of this map covers areas that aren't, but it is very interesting geology down in Devon and Cornwall. This region mainly comprises some chalk and some Jurassic sedimentary rocks in Dorset, with Permo-Triassic and Devonian sedimentary rocks up towards the north of the region. In the southwest, the near-surface geology of the region is well known thanks to the multitude of quarries, mines, coastal cliffs, and there's quite a lot of shallow boreholes as well that have been drilled. Main things that the region has been quarried for include slate, granite, and limestone. Here's a photo of Fogintor quarry up on Dartmoor, which was mined for granite historically. Also, large quantities of china clay are mined in the southwest. And Cornwall and Dartmoor, although not in the Wessex region, are very important metalliferous mining districts and produce metals such as copper, tin and arsenic, which historically were mined quite extensively in the region. In terms of superficial recent deposits in the region, they are pretty limited, and those that do exist mainly comprise sand and gravels, which are associated with some of the larger river systems. In the east, there are flinty gravels which overlie the chalk bedrock, and in some of the higher ground, such as in Exmoor, some of which is in the Wessex region, is poorly drained and contains peat deposits which can be up to a few meters thick. So the sediments in the Wessex region of the southwest were deposited mainly in shallow seas, deserts, and river systems between the ages of 25 to 300 million years ago. So these rocks do age and range quite a lot. And they were formed at a time when Britain was much closer to the equator. As you can see in this image here, this is during the late Jurassic, approximately 150 million years ago. You can just about make out the UK in the center of the image, much closer to the equator than it is in modern times. So in this part of the Wessex region, the youngest bedrock is found in the area sort of south of Taunton, and it's comprised of Cretaceous sediments deposited approximately 110 to 90 million years ago. These are formed of sandstones and clays, which form the upper greensand and gort formations, which were generally deposited in shallower seas, with the clays a bit deeper. And there's also some chalk found in this region along the coast in Dorset, capping the hills there. Here's a cross section showing some of the area. You can see the light green here is the chalk. It just shows how it sits on top of the older sedimentary rocks, forming the hills in the area. And this chalk would have been deposited in deeper seas when this part of the world was underwater. Both the the chalk and the sandstones form good reservoir rocks in the area. So underlying the Cretaceous rocks in the area, there are Jurassic sediments, which are tilted gently towards the east. These were deposited approximately 200 to 185 million years ago and comprise limestones from the Great and Inferior Uli groups and mudstones from the Lias groups. These outcrop along the Jurassic coast on the south coast of England, but also on the north coast, sort of towards Bridgewater Way. This photo here is one of the cliffs near Watchet on the north coast of the southwest of England. Here you can see grey lias in the top half of the cliff, overlying the older Mercia mudstone at the bottom. So the oldest bedrock in the area is formed from rocks from the Permian Triassic era, which are formed from a thick succession of red mudstones, which forms the Mercia mudstone, as well as red sandstones with pebble layers of mudstones, which are from the Sherwood sandstone group. And the red colouring here comes from the presence of iron oxide, with these sediments being deposited in desert-like environments. Here's a photo of an outcrop of the Sherwood sandstone group near Wellington. Here you can see different layers with some coarser gravel, overlain by some thinner, fine-grained bedded layers, which represents the different environments of deposition which were occurring at the time. So they were formed in desert environments. Here you can see the rock debris being washed down from mountains during storm events. This would be deposited in huge basins where scree slopes were accumulating at the base of mountains. And the extent of these rocks in the Wessex region occurs northeast of Chard towards the south, up through Wellington and Taunton towards the north, and then further up towards Bridgewater and Minehead. So the third region that I'll be talking about is the Bristol and Gloucester region. Here is a geological sketch map of the region. The Wessex area here only extends as far north as just south of Stroud, so approximately half of this area is within the Wessex region. This region is actually one of the most geologically varied parts of the country, and the surface geology here is reasonably well known. There are many famous geological sites in this area, such as Cheddar Gorge, Bath Hot Springs, and the Avon Gorge. This region is of particular interest to me as I live in Bristol, and for Wessex, our head office is in Bath, so we're quite lucky to be living in such an interesting area geologically. This here is a cross section of the Bath Hot Springs, and it's quite interesting. You can see how deep the water comes up from in the through the collapsed debris, which passes through many different ages of rocks, and you can see there where street level is in relation to it, and the way it's been piled underneath it to keep it stable. The surface geology of the area is well known mainly due to the good outcrops, such as the ones I've mentioned at Cheddar Gorge and the Avon Gorge, but also there has been extensive coal mining in the area. So in terms of geologically recent surface deposits in the area, they mainly comprise sand and gravel, which have been deposited by rivers. And combined with the uplift of the land, these rivers have cut deep valleys, such as the Avon Gorge and Cheddar Gorge. There are extensive deposits of clay and peat as well, up to 10 meters thick. Good examples of this are on the Somerset levels, and also along the Severn Estuary, there are lots of tidal flat deposits. This is a photo taken from Glastonbury Tor, looking across Somerset levels. So the geological structure of the region is actually very interesting, and it consists of older sedimentary bedrocks, which have been uplifted, folded, faulted, and this complex series of syncline and anticline folds was caused by the Variscan orogeny, which was the mountain building event during the formation of the supercontinent Pangaea. This happened approximately 280 million years ago. So on this cross section here, you can see these highly deformed older sedimentary beds in the purple, the light pink, and the light blue, which represent this deformation from the orogeny. But there are younger sedimentary rocks which have been deposited on top of these older rocks between 250 to 145 million years ago. And the uplift and erosion of the older rocks before the deposition of the younger rocks has resulted in these unconformities here, which you can see where Avonmouth and Gloucester are located. They are horizontal deposits on top of highly deformed rocks. So because the geology of this region is quite diverse, I've separated it into three separate regions. Here on the map, the blue dashed line indicates the section of the region which is in the Wessex Water Authority area. So the first section is from the Mendip Hills in the south towards Thornbury, which you can see with this dashed red line here. The second section I've split this area into is the Somerset Levels and North Dorset in the southern area of this region. And the third area is the Cotswold Hills, which is towards the northeast of the region, which has been highlighted with this dashed green line here. So in the first region I've designated within this region, the Mendip Hills up towards Thornbury, there are younger sedimentary rocks deposited over a rugged landscape of older rocks, which has resulted in the thickness of these younger rocks being highly variable. The youngest layers are formed from the lias, which is comprised of mudstones and limestones, and it kind of outcrops around areas such as Radstock, Whitchurch, Saltford, and Filton. The lower parts of the sequence are dominated by the Mercia mudstone, which was deposited approximately 240 to 220 million years ago in dry desert-like conditions. This Mercia mudstone can also be up to 150 meters thick in the area south of Bristol, so it forms quite a significant deposit. At the base of the hills in the area, such as the Mendips, there are large ancient scree deposits, which formed when weathered and eroded rock from the tops of the hills was washed down onto flat basins. And these scree deposits contain some cave systems, such as Wookey Hole, which is quite a famous cave in the UK, and is unusual as it's formed half in the cemented scree, which is washed down from the hilltops, but then also extends further into dissolution carved limestone blocks, which are also washed down from the hilltops. This photo here is a good example of the Mercia mudstone, which forms quite a lot of the rock in this region. And this is Orst Cliff, which is near the old Severn Bridge on the Severn Estuary. So one of the more interesting lithologies in this region are the coal measures, which are of Carboniferous age, and these were formed in shallow seas when sand and mud from rivers was deposited at river mouths and created river deltas, which then became covered in swampy forests. And as the vegetation fell into the water and broke down, it became buried and compressed and eventually formed coal. And the Bristol coalfield underlies much of eastern Bristol and extends north up to an area called Crumhall and further east to an area called Coalpit Heath. There is also the North Somerset coalfield, which is centred around the town of Radstock. This photo is called the Batch and is at a village called Poulton. This is all the material left over from the coal mining in the area and has now become a bit of a tourist attraction. So another interesting lithology in this area is the Carboniferous limestone, which is slightly older than the coal measures, which are also of Carboniferous age. This was deposited in a tropical sea between 360 to 330 million years ago, and it forms the Mendip Hills, as well as some of the other important ridges in the area, such as the hills between Clevedon and Portishead. Also, a lot of Bristol was built on a hill formed from this limestone. and there are great exposures of it in the Avon and Cheddar gorges. This photo here is taken from the Avon Gorge, looking up towards Clifton above, and you can see the tilted bedding here on the limestone, which is folded during the Variscan orogeny I mentioned earlier. So the oldest sedimentary bedrock in this area is formed of sandstones and mudstones, which are all a reddish brown color and form the Old Red Sandstone Formation. Um, these were deposited in arid desert environments approximately 400 to 360 million years ago. Then there are really good exposures of these along the ridge between Clevedon and Portishead. This photo is taken near Portishead, and you can see not only the reddish brown color, but also the deformation in the bedding here. And these rocks are greater than 800 meters thick in the Bristol area, and the true extent of these is unknown really, so they could be much thicker. So the next subdivision of the Bristol and Gloucester region we'll be looking at is the Somerset Levels and North Dorset area. So the youngest sedimentary bedrock here is comprised of the lias, which is mudstones and limestones with some sandstones overlying them. It forms the Polden Hills in Somerset um, and is exposed really well along the North Somerset coast. This is a photo between Watchet and Kilve. The cliffs there expose it quite well, and you can see the Mercia mudstone in this photo on the right hand side with a fault separating it from the lias, the grey lias on the left hand side of the photo. Now moving on to the Cotswold Hills, which is a beautiful area of the country, and some of which is within the Wessex water area, with our office actually situated in the Cotswolds. So these are hills capped by strong limestones, which are more resistant to erosion than the surrounding rocks, which is why you have such prominent hills. They're formed from a sequence of oolitic limestones. So for those you don't know, oolites form in shallow seas, such as the Caribbean at the moment. And they are layers of calcium carbonate surrounding a grain, which gets rolled back and forth on the beach and create this spherical grain. Near Bath, the oolitic limestone forms the Bath stone, which is a very famous and versatile building material, used all over the world for building quite famous structures. Here's a close-up of it. You can see the holes left by the ooids. And yeah, it's very popular because it's easy to carve and it's strong as well. So although the oolitic limestones are the main unit within the Cotswolds, there are also lias deposits, Mercia mudstones, and Sherwood sandstone deposits at a depth below the limestones. These are exposed in some of the river valleys around Bath and Frome. There is also some interesting unconformities in the area. For instance, near Frome, the Jurassic limestones rest directly on top of the Carboniferous limestone, which represents a gap of approximately 150 million years. This photo shows the Delabeche unconformity in a place called Vallis Vale. You can see the older Carboniferous limestone beds resting at an angle, and the unconformity separates them from the Jurassic limestones above, which are horizontal. So this unconformity represents a gap in time of about 150 million years. So just to finish off, I thought I'd go into a bit of detail about one of the more widespread formations in the region, and that is the Mercia Mudstone Group. It's one of the most widespread geological formations of the UK. This map here shows the extent of it. As you can see, it covers a large area in the UK. It's in the Wessex area. It extends from Lyme Bay on the south coast up through Somerset and then up to the Severn Estuary, with a lot of it underlying Bristol. It's important because it underlies several large metropolitan areas in the UK. And when we're doing ground investigation at Wessex Water, often we encounter it. So a bit of background to the Mercia mudstone. It was formed in the early Triassic. It was deposited in desert basins where there was hot conditions, it was seasonally wet, so material was washed down from hills onto these basins. Um, and it's characterized by a sequence of brown, reddish brown clays and mudstones with occasional beds of green siltstones and sandstones. This photo shows a fairly typical Mercia mudstone outcrop, and you've got the reddish brown um, mudstones with some of the greenish silty layers as well. And in the Cheshire Basin, the Mercia mudstone is in excess of 1.3 kilometers thick. So there's some really thick deposits of it up there. So as I mentioned before, the Mercia mudstone underlies a lot of important metropolitan areas in the UK, one of which is Bristol. So some of the work we do is in Bristol. And these are some of the geological hazards and geotechnical problems which are associated with the Mercia mudstone. So one of these is that it can vary between being classified as a soil or a rock, and this depends on the state of weathering, where usually you have a weathered surface towards the top of a unit, but with the Mercia mudstone, it can vary quite drastically with weaker material sometimes being found beneath stronger material due to the different ways it weathers. It also may be subject to shrinking and swelling due to water content in the unit. This can result in structural damage to buildings. It also contains evaporite minerals such as halite and gypsum, which form in the desert environments when it's deposited. But these minerals are easily dissolved by groundwater, which can end up leaving gaps or voids in the ground beneath buildings, so it can cause structural issues. And also, the Mercia mudstone may contain aqueous solutions of sulfates and sulfuric acid. And the main risk of these is that they can attack concrete chemically and cause further structural damage. This photo is a scanning electron microscope image, and it's showing the black areas are showing sulfate attacking concrete. So you can see how the effect it can have on concrete. So that brings us to the end of this presentation. I hope you've enjoyed it. I hope you found this interesting, maybe learned something. A few conclusions here just to sort of finish off with. So Wessex Water covers an area which is very diverse with geology, and we're quite lucky actually to be living somewhere and working somewhere with features such as the Jurassic Coast nearby, and obviously the Cotswold Hills, the Mendip Hills I mentioned. The region also has some important resources, including groundwater zones, which obviously working at Wessex Water is important to us. We have a lot of famous geological landmarks. I just mentioned the Jurassic Coast, the Avon Gorge, Cheddar Gorge. And for us, it's important to find out the ground conditions at the site. And this is what we do by conducting ground investigations. We help people to understand the geology so then we can design structures how they need to be constructed for particular areas where the geology may vary. And just some references to finish off. I'll leave them up if anyone wants to check them out. But yeah, thanks everyone. I hope you enjoyed this and hopefully you managed to learn something from it.